In this lesson, we're going to be faced with some problems like this, where the denominators are different. They are tenths and hundredths. And we're going to look at how we can add or subtract fractions with denominators of tenths or hundredths. Let's take a look at this explained. Every fraction with a denominator of 10 can be written as a fraction with a denominator of 100. Part A, the model at the right is divided into 10 equal parts, or tenths. How many parts are shaded? I've counted those up and there are 7 shaded parts. Part B, if you split each tenth into 10 equal parts, the whole is now divided into 100 equal parts, or hundredths. Now, how many hundred parts is that now shaded? And that would be 10 in each column. 10 times 7 would be 70. That's 70 parts shaded. Now, let's look at part C. Complete the equation to show a fraction with a denominator of 100 that is equivalent to 7 tenths. So when we started out as 7 tenths, we know that really is equal to 70 hundredths. To do that, I'm going to multiply my numerator and denominator by 10 because I cut each part into tenths. Now, 7 times 10 is 70. 10 times 10 is 100. So 7 tenths is equal to. Part D, you can also use money to think about equivalent fractions with denominators of 10 and 100. Think of $1 or 100 cents as the whole. Now let's fill in these blanks. I love this because 1 dime is like 10 pennies, and that makes sense to me. So 1 dime is equal to 10 cents, which is 10 hundredths of a dollar. 1 dime is equal to 10 hundredths of a dollar. 1 dime is also equal to 1/10 of a dollar. So 1/10 is equal to 10 100ths. I think about it like this. This would be 1 dime. This would be 10 pennies, and they are equivalent to each other. Let's take a look at this problem. Carmen has 4/10 of a dollar. Troy has 50 100ths of a dollar. Together, what fraction of a dollar do they have? So I've written down our equation, 4/10 plus 50 hundredths. Okay, here's an example of how pictures can help us with this problem. Carmen has 4/10, which is like 4 dimes, and Troy has 50 hundredths, which is like 5 dimes, or you could say 50 pennies. Together, they have 9 dimes. And here's how models can help us solve this problem. We see Carmen's money is 4/10 shaded. Troy's money was 50 hundredths shaded. And then we see how they are totaled together, how they look together, and that equals 9 tenths or 90 hundredths. Okay, to wrap up this problem, let's look at our problem again. We have 4/10 plus 50 hundredths. And it says, what are the denominators? Are they the same? No, they're not the same. We see tenth and hundredths. So in step 2, I've gone ahead to change 4/10 into hundredths, 40 hundredths. Now I can be at step 3 and I have what I need to add. I have same denominators. So 40 plus 50 equals 90. 100 stays the same. And we can say that that's 90 hundredths, or we can call it 9 tenths, and they will be the same. Okay, to close up, I want to go back to this question that we started out with, 14 hundredths plus 6 tenths. Notice that I kept 14 hundredths the very same, but 6 tenths I changed to 60 hundredths. And that's like I learned by multiplying times 10 times 10. Together they add up. 14 plus 60 equals 74 100ths.